Hey, good afternoon, Mr. Testa.
Good afternoon.
Thanks for meeting with me. How's everything going?
Good. How are you?
Good. Just a lot of stuff going on, but good. So I wanted to sit down and debrief and talk about the class I came and observed and just see how you felt it went, and then to give you some ideas of what I saw and just talk through some things on our corrective action plan. Okay? So I came in 2 days ago, and you're working on the learning target that us as a group are trying to work on in our class. I can create an equation from a word problem or a problem that I have. So I saw when you came in, I saw that you had your students working and really on task and functioning. Can you just tell me how you felt that observation went, or how you felt the lesson went, before we actually just dive into what we both saw?
Right. So my kids, I'm trying to relate it to what I'm doing in class right now. So we're working on y equals mx plus b. So the word problems that I gave were word problems that they could relate to in certain ways, whether it be money or distance or something along those lines. So the word problems, for example, one of them was if you're growing a plant and the plant grows 1.5 centimeters per day, and the plant started at 5 centimeters high, write an equation for that line, or write an equation for that situation. So the first thing is just getting them to identify which one is the slope and which one is the y-intercept. And then they create the equation by filling in those two things to the y equals mx plus b form. So the big thing is just language and having them understand what to look for in order to identify which one's slope and which one is y-intercept.
So when I came in, it was very good. You had a great flow. Like, your kids are very on task. They seemed like the activity that you were doing, it seemed more of like an inquiry kind of in the beginning, where you're trying to get them to figure out what the y was, what the slope is, and all that. I like how you were really pushing them to actually be critical thinkers and to think on their own. It was very good to see you do that. Some follow-up feedback that I had, seemed like your students were struggling a little bit with the language, and I love that you identified that. Just actually within those problems, identifying those key words to actually help them know what is what when they're setting up the equation. So I did notice some of your students were struggling with that. The majority were getting it, but I saw a small percentage still struggling with those key terms within those problems to actually know how to set up the equation. And I know my students struggle with that. We're using the Pythagorean theorem, and they're still struggling with what's the C, what's the A, what's the B. So I want to see if we could talk through some strategies and maybe come up with some solutions to actually help them actually know what is before they even set it up.
Okay.
Have you thought of anything already? Or?
No.
Because I thought about, unless you had one.
No, I know.
I thought about actually revisiting our strategy cubes, because I realized it wasn't really being utilized that much during that lesson.
Right.
And I thought that maybe that would be something that could actually bring it back for them to actually pull out, okay, what is letting me know that this is the y-intercept right here?
Right.
What's letting me know that this is? Maybe those little.
So I've told them that the y-intercept is usually identified by language surrounding where you started. So for example, the word problem that I said earlier said, today the plant was 5 centimeters high.
Okay.
So, and then in relation, in terms of slope, the word problem said the plant then grows 1.5 centimeters per day. So I tell them to look for that word per or every or each, because that usually identifies something that's continuous, and we know that slope is continuous movement.
So that's their action word, their identifying word.
Per.
So they can be boxing that.
They could be boxing that
with our
relating
strategy.
to the strategy. Yeah.
Cubes. Okay. How has that been working for them with when you tell them the per?
They seem to get it. Going through and grading them, a lot of them will either flip-flop them altogether,
Okay.
Or they will get identifying both of them right, but then putting them into the equation in the wrong place.
What do you think is getting them to put it in the wrong place, though? What do you think is?
I'll be honest, I
trigger?
don't know, because then when I point out and say, well, which variable represents slope, they're able to say m, but they're not related. I'm not sure where the disconnect is between the question or the part of the question that says identify the slope, and then the part where they have to plug it in and actually put it in for m.
Do you think it could be they just need more practice?
I think so.
Have you set up any ways for them to continually practice?
Oh yeah. I mean, we're not giving up this topic just yet. We have a little bit more to do in it, but even afterward, I think we're in a very graph-centric area of the curriculum right now. So just maybe sneaking in, trying to find a way to sneak in a problem every now and then, whether it be warm-up or exit.
I was thinking of probably an activity because it made me think of, because you had some really strong students who were getting it, and then you had a few some that were missing the certain things, and I thought about them relating back to our strategy that we're using in our department to the boxing part and having them really identify those key terms. And I thought of trying to maybe come up with like a station activity. And maybe you can have like the students that were getting it to be like the leader at certain stations. So it kind of will support, because it's kind of hard when you're just one teacher. So it kind of support you in the way of where you have other supports and they're in smaller groups so they can actually target.
Right.
Because sometimes I find that, especially with my students, and my students are the ones you had last year, I find that it just could be the little small thing that another student can tell them that would actually help them grasp it than us saying it over and over. So, would you be interested in trying a station activity?
Yeah, that'd be interesting. That would, because I think in each class I do have a few students who would be able to lead a group of their peers in that.
And I think it even can be good, 'cause I know you might be moving on to another topic, but I think you can even still have it where like you move on to the other topic, but you still have that station where like that one activity can be like you have two stations relating to this topic of the equation, but you've moved on to one station that has the graphing. So it's like that rotating where they'll come to you for the graphing part, or another one has like the motion of the graphs, and then the other one has the equation that they're setting up. So we can actually work together on setting that up, and like I can even come in that day and do a station with you if you would like. I would love the idea to come in and do that.
That'd be fun.
So when is a good time for us to actually like check in and actually help set up that? When's a good time for me to come in?
Well, as you know, I'm going away. I'll be returning Tuesday.
Tuesday?
So we could always meet on Tuesday during planning. And
definitely, I can meet with you Tuesday. We can talk through the ideas, see where I can help fit in. We can pull some stuff. Do you think we can pull something from like Agile Mind? Does Agile Mind have any specific like activities around that?
They don't have many activities, period.
Okay.
But they may have some practice examples or something like that.
Okay, so we can pull some of that and actually work through some of the problems. We actually do some of the problems and see where it
They
can
be built up from station to station.
Yes, like that. Oh, I just had an idea. I haven't done it in a while, but do you do error analysis?
Yeah, actually I just did it today.
How did that go?
So the actual error analysis I did was more the error was more in the language rather than the actual calculations.
Okay.
So for example, the problem was 2x plus 5y equals 85. And it had to do with sodas and sandwiches. And the work that was done out, it said if Tim buys 15 sodas, how many sandwiches did he get? But, so I plugged in the 15 in the sandwich rather than the soda variable. So all the rest of the work was good, and it was perfect. So that's really tripping them up.
Oh.
But when I tell them to look back at the language and the variables, they're like, oh, okay, now I see that he just plugged into the wrong variable.
And that's good because you said that the issue where they were struggling the most was with the language. So I like that. I would love to do. I probably can even take that as my station, or we can work together on that. Do like an error analysis, like one station be an error analysis where they have to work through the problem and try to figure out the mistakes. I noticed that when students are given a problem, like you just said, and they have to figure out what's wrong with it, it causes them to think even more.
And it hurts their head.
I know. It does hurt their head, but we have to push them to be that way.
Oh, absolutely.
Yeah. Like, I just want to say thank you so much. Like, coming into your class is actually very refreshing. It's good to see like where we've grown together, like moving forward on this like path of us and developing and everything. And I'm excited to come work with you and come back into class.
Thanks.
Thank you, Mr. Testa.